All right, so here's our next example on Newton's law of cooling. So this is your standard cup of coffee example where we have a hot cup of coffee at a temperature of 200 degrees Fahrenheit and it's left in a room at 70 degrees. 1 minute later, we find that the coffee has cooled off to 190 degrees. So determine when the coffee will reach a temperature of 110 degrees. So again, we have a basic equation that we're going to be using, which we have derived earlier. Our basic equation is, it's worth repeating it just as a reminder, temperature at any given time T equals m plus c times e to the negative kt, where m is the temperature of the surrounding medium, capital T is the temperature, lower t is the time. So for this question, what do you think is going to be the value of m, the temperature of the surrounding medium? So it was left in a room at 70 degrees, right? So the temperature of the surrounding medium is, in this case, temperature of the room. That's where the coffee is cooling. So that happens to be 70 degrees. Now, again, it helps to do a very rough graph for these questions. So typically, if an object is cooling over time, and it's going to eventually reach whatever temperature of the surrounding medium is, it's eventually going to reach that temperature. So in this situation, this horizontal asymptote where it's going to eventually become, that's 70 degrees. And also remember, this horizontal axis is time, vertical axis is temperature, and time equals 0 over here. So initially, this cup of coffee was initially 200 degrees Fahrenheit. So here I'm going to put the number 200. And again, my graph is not up to scale or anything, but it's just a visualization, just giving me an idea about what is happening and what is it that I'm going to try to solve for here. So 200 degrees, a very hot cup of coffee. Okay, then what we also know is 1 minute later, coffee has cooled off to 190 degrees. So let's say right about here is 190, and that happens when t is equal to 1. Because time is given to us in minutes, we're going to use it in our problem, so the final answer will also turn up in terms of minutes. So what else do we know? So 1 minute later, the coffee is cooled off to 190 degrees. They want to know, when does the coffee reach a temperature of 110 degrees? So we know somewhere below here and above 70 is 110. Again, very, very roughly speaking. So we would like to know, when does that happen? When is it going to be equal to 110? So what is the temperature? What is the time when the coffee is cooled off to 110? Because that's when perhaps the person is going to drink the coffee. They would like to know exactly, scientific precision as to when the coffee will be in the perfect shape to drink. So to answer that question, let's first write everything that's given to us in terms of an equation. We know initially the temperature is 200, so capital T of 0, when time equals 0, temperature is equal to 200. That's given. In addition, we know 1 minute later, T of 1, it has cooled off to 190 degrees, right? So T of 1 is 190. Okay, and then what we'd like to find out is, when is it exactly 110 degrees? So T, capital T of lower t, time, equals 110. When does it happen? Solve for lower t, the time. So here's our general equation. Here are the two things that we know, which is going to help us figure out c and k. We already know m. And from there, we can easily figure out the time by setting the entire equation equal to 110. So you see, the first example was perhaps a little bit confusing and it looked really long, but you'll find that after you do one example, the next few ones, you can do them much faster because there's a very repetitive process here, as you can see. Okay, so the best thing to do would be right now to stop the video for a few minutes, try this on your own, and then come back and check. All right, so hopefully you're coming back. Spoiler alert, I'll go over the solution here. So if you need more time, please pause the video. So we know what m is, 70. I can directly go ahead and put 70 into that equation. And I have 70 plus c times e to the negative kt. And using the first equation, when time equals 0, plug in 0 in here, this whole thing will be 1. So you're going to have c times 1. And set the entire equation equal to 200. So t of 0 is 200. That basically means plug in 0 for time and set the whole thing equal to 200. So we know that this part is going to be equal to 1, e to the 0, or k times 0 is still 0, is 1. So c times 1 is c, right? So to solve for c, simply subtract 70 from both sides. So c turns out to be 200 minus 70, or 130. Okay, so now that we know c, let's go ahead and plug that in this equation. So now our equation is capital T of lower t equals 70 plus, we just figured out k, right, plus 130 times e to the negative kt. So we've used this equation so far, and we figured out capital C. And now we can figure out lowercase, the constant k, by using this equation. Okay, so t of 1 equals 190. So for lowercase t, go ahead and plug in a 1 here and plug in a 1 there, and set the whole thing equal to 190. So 70 plus 130 times e to the negative 1t. So 70 plus 130 times e to the negative 1 times t equals to 190. I just happen to put the 190 first, doesn't really matter, right, whether you put on the left or the right. So 190 equals, just plug in 1 for time. That's what I did. Now, to solve this equation, first step, I must subtract 70 from both sides. So do a minus 70, you'll get 120 on the left. This 70 will disappear. So we have this. And now to solve for k, first divide by 130. So you're going to have, and this, you can also divide by 10 after that, top and bottom. So you have 12 over 13 equals to e to the negative k. So again, you can, if you like, just get rid of those to make the numbers a little bit smaller, and then apply natural log to both sides, right? And solve for k. So apply ln to both sides. And of course, ln of e to the negative k, ln e basically is 1, or you bring the negative k down, negative k times 1 is negative k. At this point, divide both sides by negative 1 to solve for k, and you get a value. Again, remember to use lots of decimals, or keep it the exact value all the way until the end if you prefer. At least I would say 4 or 5 decimal places. Okay, now that we have k, we're going to go back to this equation. Okay, so we know c. Actually, let's go back to this one where I already entered the c, right? So now let's also enter the k into this equation. So the temperature at any given time equals 70 plus 130 times e to the negative, the value we just got, right, times t. And why am I setting it equal to 110? Because the question was, figure out at what time is this cup of coffee equal to 110 degrees? That was the question, right? That's why I'm setting it equal to 110. And now to solve for time, I need to subtract 70 first. That'll give me 40 on the right-hand side. So I subtract 70 from the side, it disappeared here. Subtract 70 from here, I got 40. And now the rest should be straightforward, right? So you divide both sides by 130 and then apply natural log. So divide by 130. If you like, you could cancel the zeros because divide top and bottom by 10. Apply natural log to both sides. So natural log of this side is equal to natural log of this side. And here, once again, same idea, right? ln e of a power, you bring the power down, ln e is 1, you'll just have the power showing. And I even skipped one step there to save time. Basically, when you bring this down and you want to solve for t, you're going to have to divide by that constant, right? So that's what you see over here. So natural log of that ratio, 40 over 130 or 4 over 13, divided by the negative 0.080043. That will give you the time. Now remember what this time represents. This is a time from the initial, from time equals 0. So that's the time when it was placed in the room, when the coffee was placed in the room. So from that, or when it was freshly poured. So it will take 14.7 minutes from the moment it was poured to get to the temperature of 110 degrees when it will be reasonable to drink it. All right, and then the last example, I'd like to give you a little bit of hint about how we can solve a murder mystery. So that will be next. All right, and here's that murder mystery problem I promised you in the first segment. So let's take a look. So let's suppose that a murder victim is found at 8:30 a.m., that the temperature of the body at the time when the body was found is 30 degrees. Assume that the room in which the body was found is 22 degrees Celsius. And so suppose they measure again the temperature 1 hour later, that it was 28 degrees. Using this information, determine the approximate time when the murder occurred. And here everything is given in terms of Celsius, and we're going to assume that healthy body temperature in terms of Celsius is 37 degrees. You can assume that's a given quantity, it's a known quantity. So initially the body was found and the temperature was 30 degrees. 1 hour later it was 28 degrees. The room temperature where the body was found is 22 degrees. And assuming a healthy body temperature is 37, can you figure out when did the person die? So again, this is some kind of a cooling problem. So this is the cooling of, in this case, body temperature. So eventually the body will be same temperature as the surrounding medium. In this case, it's the room that it's in, so it's 22 degrees. So eventually it will become 22 degrees. But at the moment when it was found, let's call that moment time equals 0, when the body was first discovered in the room. So that is the temperature when it was found, that was 30 degrees. So what we're going to have to do in this problem is we have to figure out when the time of death is, and assuming that this was a healthy person with a temperature of 37 degrees, so we need to know when was this body 37 degrees Celsius. So basically that was before it was discovered, right? So we're going to go to the negative territory over here a little bit. So let's say maybe over here, we don't know when the time of death is, but at that point, the temperature was 37 degrees. So your answer here is going to be negative, okay? Because we're assuming time equals 0 corresponds to when the object was found, when the body was found. So if you get, let's say t equals to, let's see, is it in terms of, yeah, everything's in terms of hours. So if you get t equals negative a half, that means, you know, the time of death was half an hour before the discovery. So you would just subtract half an hour from here. You'll say time of death equals 8 a.m. Okay, so that's how we're going to solve the problem. You're going to find t equals a negative value, and from there you're going to figure out the time of death by subtracting it from this time when the body was found. Now, I'm not going to solve this entire question. I'm giving you some hints, but it's very similar to the last two problems or last example that we looked at. And in this situation, let's just write down what's given to us in terms of equations, okay? So temperature initially when the body was first found. What is your answer? If you said 30, you are correct. It was 30 degrees initially. Okay, what else did they know? 1 hour later, temperature was equal to 28 degrees Celsius. And what are we supposed to find? Find the situation when T of t, temperature at time, equals lowercase t. Find when temperature equals 37, which is the temperature of a healthy person in Celsius, everything in Celsius. Okay, so your job is to figure out the time. Remembering that time will be negative, you'll come back here and you're going to subtract it from here, and that'll be the time of death. So now you have a few things to do, right? Very similar to the last example or the previous one. Start with putting M in place, right? What will you put for M? Temperature to surrounding medium, and that's your the room temperature, right? The room temperature is a constant of 22 degrees. Then use this equation, plug in time equals 0, right, into the little t, and put M equals 22 already, and set the whole thing equal to 30. You're going to be able to get C. And from there, I'm going to erase these extra things so they don't get confused with the constant C, the Celsius. But let's just keep in mind that it's not Fahrenheit, everything's in Celsius, but you don't have to put it there. So you're going to be able to solve for this constant C using the first equation, right? Then use the second equation to determine your K. And finally, once you know your equation with all the constants filled in, you'll be able to set the whole thing equal to 37 and solve for time, okay? And when you do this problem, I'd like for you to go to the lecture notes. You're going to find that there are at least a couple more unsolved problems, and so you can go back and also solve those. I didn't want to overload you with too many problems in this chapter because these questions are relatively long. So if you do, I think, like a total of 5 of them, they're very repetitive in nature. I think you're going to be able to get it, and you don't need a million problems, and they're very time consuming. So therefore, when you're done with this question, I'm going to show you the answer in a few moments. Please pause the video, come back and check your answer, and then go back to the lecture notes and do a couple more in there, and then that'll be your practice for this section. There's not a separate assignment or a group activity. Just do the lecture problems and the ones in the video and the ones I haven't solved, but I gave you the answers in the lecture notes. Okay, so please pause the video and come back in a few moments to see the answer. All right, so I do hope you had a chance to solve the problem, and now I'm going to show you the solution, rather than just to find the answers for you to check it. So if you did all the constants correctly, you should have gotten this equation. 22 plus 8 times e to the negative 0.2877t. And then if you solve the given problem, so we want to know when was the object equal to 37 degrees Celsius, and you set the whole thing equal to 37, you solve for t, you will get approximately negative 2.18 hours. Since given time was in hours, our result is in terms of hours. So negative meaning is 2.18 hours prior to object being found, the body being found. That's when the time of death was. And it sometimes helps to convert that into minutes. So 0.18 hour is 0.18 times 60. That is about 11 minutes. So 2 hours and 11 minutes before the object was found. So since it was 8:30 when the body was found, so if you subtract 2 hours, that'll be 6:30, and subtract 11 minutes, it'll be 6:19 a.m. So we estimate the time of death to be approximately 6:19 a.m.